Hello everyone, it's me Indramani Gewali, math teacher for grade 9. Welcome you all in today's class. So today we are going to learn about Hcf and Lcm. So basically what is Hcf and what is Lcm? This is the first class of Hcf and Lcm. So in the very beginning of the class, I am going to talk about some of the numbers like natural numbers, and I am explaining what is Hcf and Lcm with the help of the numbers. But later, in case of grade 9, we need to practice Hcf and Lcm based on algebraic expressions with some numbers, natural numbers. So let me introduce what is Lcm and Hcf. For the better understanding of Hcf and Lcm, we need to know some of the terms like multiples and factors. What are multiples and what are the factors of numbers or algebraic expressions? So let me take one short example and explain what are multiples and factors of any number. Let's see what are multiples. Multiples. Let me take an example, the natural number 5. What are the multiples of 5? We know its multiples are simply what is 5 times 1, 5, what is 5 times of 2 is 10, what is 5 times of 3 is 15, and so on. These are the multiples of a number 5. Similarly, what are the factors of any number? I am taking number here. So what are the factors of 12? Factors are those numbers which divides a given number exactly. So here we can factorize 12. There are different ways, but I am writing all the factors of 12. So we can divide 12 by 1. So 1 can be the factor. We also can divide 12 by 2. 3 is also exactly divisible. So 1, 2, 3, 4, 6 and 12. These all are the factors of 12. What are factors of 12? Factors of 12 are 1, 2, 3, 4, 6 and 12 itself. 12 is divisible by all these numbers. So we say these are the factors. So 12 is divisible by 2, similarly by 3, 4, 6 and 12 itself. This is the basic concept of factors and the multiples. Now, what is LCM? LCM is the lowest common multiples of 2 or more than 2 numbers or algebraic expressions. Least common multiple. And similarly, what is HCF? HCF is highest common factor from all the expressions or numbers. Highest common factor of 2 or more than 2 numbers or algebraic expressions. So I am taking example and then I will make clear what is HCF and LCM. Let's take an example. 3 and 8. So I am taking two numbers 3 and 8 and explaining what is HCF and LCM. Along with this, I am also going to talk about the different features or properties of HCF and LCM. For this, first of all, in the beginning, we need to find out the factors of the given numbers. So what are the factors of 3? What are the factors of 8? There are many ways to find HCF and LCM, like we can say prime factorization or division method. In case of numbers, the best way is factorization process. So here I am writing the factors of 3. So what are the factors of 3? 1 times 3 3 is a prime number. Similarly, what are the factors of 8? We can factorize it. 8 is 2 times 2 times 2. These are the prime numbers. 2 is prime number. And obviously 1 is the factor of each number. 1 is the factor of each number. Now what is HCF? HCF is the highest common factor from these two numbers. So here, what is the common factor? We can say 1 is only the common factor in 3 and 8. So if there is no other common factors, 1 is always common factor and its HCF is 1. So what is HCF? HCF is 1. HCF is 1. Similarly, let me find out LCM. What is LCM? LCM is lowest common multiple of the given numbers. So here, what are the two numbers which are given, 3 and 8? We can guess what is the least number, smallest number, that is multiple of 3 and 8. We can simply guess this and find LCM, or we can use factorization process. So I have written here the factors of 3 and 8. So the way of finding LCM is, in the beginning we factorize, we write the factors, then we pick out the common factors if there is any. If not, we will write all the factors from given numbers, and the product of common factors and rest of the factors gives always LCM. So here none of the factors are common, so we simply find product of the remaining factors from two numbers to find its LCM. So from the first number 3 times, from the second 2 times 2 times 2. So 2 times 2 times 2. So what is the product? 3 times 2 is 6, times 2 is 12, times 2 is 24. So what is LCM? 24 is LCM of two numbers 3 and 8. Here I have written 1. 3 times of 1 is 3, because to know what is the HCF, 1 is common factor, 1 is the factor of each number. That's why I have written 1 here, to make every one of us clear. These are the HCF and LCM. Now what are the important features of HCF and LCM? What are the important properties of HCF and LCM? Let me talk about this. HCF times LCM is always equal to first number times second number. So let me write here, this is one of the property of HCF and LCM. So HCF times LCM is equal to first number times second number, and this relation is true only for two numbers or two algebraic expressions. I am taking here two numbers, so this relation is true only for two numbers or two algebraic expressions. So HCF times LCM is equal to the product of first number and the second number. So we can verify this relation with the help of the same example. So what is HCF? In this example, what is HCF? 1 times what is LCM? LCM is 24 is equal to what is the first number? 3. What is second number? It's 8. This relation is true. 24 times 1 is 24. What is 8 times 3? 24. So this relation is true for any two numbers or any two expressions. Similarly, we can take other examples in terms of number, but basically here we are going to talk about different algebraic expressions. Hcf and Lcm has other properties as well. Like, let me take next example here. Let me take next example here. I can take example 3 and 6. 3 and 6. 3 is first number and 6 is second number. So what is HCF? HCF of 3 and 6 are the numbers that are common to both. So what are the common factors? For this, 3 is 3 times of 1, 6 is 2 times 3. 1 is always common. So we don't need to mention this. 1 is always common to all the numbers and algebraic expressions. What is the common factor? We can pick out common factors here. 3 is common. So HCF is 3. What is LCM? LCM is, for finding LCM, first of all we take common factors. So what is the common factor? 3 times the remaining factors. So LCM is, basically we calculate LCM by finding common factors and then multiplying common factors with rest of the factors. So in the first number we took 3 common. In the second number 6, 3 is common. Now 2 is the remaining factor of 6. So what is LCM? 3 times of 2 is 6. I am connecting this example with two properties, or there are others, so I am discussing about 2 now. So HCF of any two numbers or more numbers is never greater than any of the given numbers. So what is the HCF? 3. So HCF of two numbers or more than two numbers or expression is never greater than any of the given numbers. Similarly, LCM is never smaller than any of the two numbers or more than 2, any of the given. Now let's practice some of the questions based on algebraic expressions. So we are going to learn HCF and LCM in some of the questions. Let me take first example here. First example, find HCF and LCM. HCF and LCM of 3x square y and 9x y square. So this is first question. So I am taking here, find HCF and LCM of 3x square y and 9x y square. So in the very beginning of this solution, first of all we need to factorize both expressions, algebraic expression here. So this is first expression and this one is second expression. Let's write first expression. First expression here is 3 x square y. Let's factorize this expression. 3 is same times x square, we can write x times x multiply by y. These are the factors. Similarly, what is second expression here? Second expression second expression is 9xy square. We can factorize 9. 9 is 3 times 3 times x times y multiplied by y. Now, HCF is common factors. For HCF, now we take the common factors from first and second expression. Now let's write, or we can pick out the common factors. So what are the common factors? 3 is 1. Similarly, x is also common and y is common. What are the common factors from these two algebraic expressions? 3 is one common factor. Similarly, x is also common and y. Then HCF is product of all the common factors from the given expressions. So therefore, HCF is product of all the common factors. So first of all, 3 times x y. So 3xy is HCF. Similarly, now what is LCM? LCM is product of common factors, or LCM is HCF times rest of the factors. So what are the common factors? Again, 3, x and y are common. Now let's pick out the remaining factors from first expression, which is x. Let me write here the common factors, the same 3xy, this is HCF, or common factor from first and second expression. Now which factor is left in first expression? It is the remaining factor, x times x multiply by what are the remaining factors in the second expression? 3 and y. So 3 times y. So this is equal to, what is 3 times 3? 9 x is square y. 9 x is square, y times y is y is square. Y times y is 9x is square, y square is LCM. We also can get idea from the Venn diagram, though we do not use Venn diagram method here for understanding. Let me draw a Venn diagram here and explain what is HCF and LCM. I am drawing one overlapping diagram here. In general, we do not use this, but this is only for concept. This is the intersecting region. This is intersecting region of two circles, and this is the common region. So you can say this is HCF. And what is this first circle denotes? This is first expression, and this is second expression. This is second expression and this one is first expression. And this middle region, this is intersecting part, common part, is called HCF. We can say this is common region of two circles here. So this is common region is HCF, because what is HCF? Common factors from given numbers or algebraic expressions. So what is HCF? HCF is 3xy. 3xy is HCF, and this is first expression. Now what are the factors left in first expression? Only x. What are the factors remaining in second expression? Remaining factors of second expression are 3 y and x. So we can fill this and get idea about this Hcf LCM. So LCM is product of x 3xy and the third reason we can try with this. This is only for concept, and we do not need this diagram for finding Hcf and LCM. Now let me take some other examples of Hcf and LCM. Let me write here one example: a square minus 9 and a square plus 4a minus 21, and we are going to find Hcf and LCM with the help of these two algebraic expressions. First of all, what is the first expression? First expression here is a square minus 9. In the beginning, we need to factorize the given algebraic expression, and then we will find common factors for Hcf. So for this we have done factorization in previous classes. Let's recall and factorize this expression. We can convert this into a square minus b square form and use same formula. So what is formula of a square minus b square? Factors are a plus b, a minus b. What is a? So a is same, a plus b is 3 times a minus b. These two are the factors. Similarly, now let's take second algebraic expression and factorize this. Now second expression here is a square plus 4a minus 21. This is there are three terms in expression. Now let's find two numbers whose product is 21 and difference is 4. We can think and split the middle term. What are two numbers whose product is 21 and last term, sign of last term now in this case determines sum or difference. So last term is negative. So two numbers whose product 21 and difference 4. What are the numbers? We can factorize 21 for this. 3 7 times is 21. So we can split middle term taking these two numbers 7 and 3. 7 times 3 is 21. 7 minus 3 is 4. In this way we can factorize this expression by splitting the middle term. A square plus 4 is 7 minus 3 times a minus 21. So this is a square plus, now let's open bracket, a square plus 7a plus minus minus 3a minus 21. We can take common from first two terms and then next two terms. What is common from a square plus 7a? So common factor is a, so a plus 7 minus what is common from 3a and 21. So 3 is common, 3 a plus 7. After taking negative sign common, we need to change sign in the bracket because minus 3 times of a is negative 3a, minus plus becomes minus, so 3 times of 7 is 21. Again, now we can see in the bracket there is one common factor which is a plus 7. Let's take this factor common. This is equal to a plus 7 times a minus 3. these are the factors. Now we have factorized two expressions, a square minus 9 and a square plus 4a minus 21. What is HCF and what is LCM? So therefore HCF is highest common factor, or simply we can understand what are the common factors in first and second expression. Let's take what is common factor. A minus 3 is common factor, so HCF is a minus 3. Now what is LCM? LCM is product of common factors and rest of the factors from the given expressions. So first of all, let's pick out the common factor. So what is common factor? It's same, a minus 3 times now the remaining factors from first expression is a plus 3. What is the remaining factor in the second expression? A plus 7. Now we can combine these two factors, a minus 3, a plus 3. It's similar with the formula a minus b, a plus b. So we can combine these two. A square minus 3 square is 9 times a plus 7. So a minus b, this is a minus b term, and this is a plus b factor. So we can combine. What is product of a minus b, a plus b? A square minus b square. So a times a is a square, 3 square is 9. If we want to learn this with the help of the diagram, say here, this is not necessary, this is only for concept. What is the common factor? A minus 3. So a minus 3 is common factor. What are the remaining factors in the first expression? This is first expression and this is second expression. What are the remaining factors in the first expression? A plus 3, we can write here a plus 3. And what are the factors remaining in second expression? A plus 7. Sorry, it's a plus 7. So this is HCF. The common intersecting region gives HCF, and LCM is product of all the numbers, all the factors, a plus 3 times a minus 3 and a plus 7. So this is for today, and we will continue the same topic in next class. Thank you everyone for watching live class. Thank you all and stay safe.